Okay, if you've completed the first 3 lessons, you're now halfway through this review unit. We're going to move on today by working with fractions. Not many people like fractions, but in a lot of places we come across them. So it's good to know how to deal with these. We're going to show you step by step how we can work each operation with fractions. We're going to start with multiplying fractions. 3 easy steps for multiplying fractions. First thing we're going to do is multiply the numerator. Now numerator, that's just a fancy math term for the top number. So we're going to multiply the 2 top numbers together. So if I look at this first example here, 2 times 6. Now 2 times 6, that's 12. So that's pretty easy so far. Second step, after we've got the top number figured out, we're going to multiply the denominators. And if the numerators are the top numbers, the denominators are the bottom numbers. So basically we're going to multiply the top numbers together and we're going to multiply the bottom numbers together. So going back down here, 7 times 5 on the bottom is 35. So there we've multiplied our 2 fractions together. 2 sevenths times 6 fifths is equal to 12 35ths. I'll come back to that third step in a moment here. If we move on to the next example, again we're going to follow step 1 and 2, multiply the top numbers or the numerators, multiply the bottom numbers or the denominators. 10 times 3 is 30, and 9 times 4 is 36. So that's all well and good. When we multiply these together, we get 30 over 36. But this is an example where we actually have a third step. And for step 3, we're going to reduce if possible. Okay? Now what that means is that we're going to make the numbers smaller so that they're a little easier for our brains to think about. Okay? Now how do we make the numbers smaller? Well, what we want to do is we want to look for a number that can divide into both the top and the bottom number. Okay? I always like to work with small numbers. So I recognize that 30 and 36 are both even numbers, so I know that they will both divide by 2. So I can take both numbers and divide them by 2. If I get 30 divided by 2, well, that's now 15. And 36 divided by 2 is 18. So I can make these numbers smaller. 30 over 36 is the same as 15 over 18. It just looks a little bit different because we've made the numbers smaller, but they're still proportional or equivalent to each other. Now I always want to check to see if I can make things any smaller. And if I think about this, well, 15 doesn't divide by 2, but 15 and 18, they both divide by 3. So I can make them a little bit smaller still. So if I do this one more time, 15 divided by 3 is 5. And 18 divided by 3 is 6. Okay? So again, all of these mean the same thing, they just look different because of the values, but they're all proportional. So we could think about 30, 36 is if we have 30 slices of pizza out of 36. Numbers are big, it's a little hard to comprehend, but if we have 5 out of 6 slices, we can sort of visualize a pizza in 6 slices and then figure out what 5 of those are. So it's a little easier for us to think about how big this number is when we're looking at the smaller numbers. If I go back to this first example, I didn't reduce this one because there is no number that nicely divides into both 12 and 35. 2 goes into 12 but not 35. 3 goes into 12 but not 35. 4 goes into 12 but not 35. Okay, so we can try some different possibilities. We don't want to end up with decimal numbers. Okay, so just like when we looked at the changing the decimals to the percents to fractions in the last lesson, we don't like to have decimals in fractions. Okay, so only do this if they work out to nice whole numbers. Now this one looks a little different because we actually have a whole number with a fraction. So how do we multiply a whole number with a fraction? Well, what we can do is we can make this whole number a fraction. And we can do this with any whole number. just by putting a denominator of 1. Okay? So if we think about 4 as 4 pizzas, okay? Or we can think about 1 as the whole pizza, and then we have 4 of those whole pizzas. Okay? Once we see two fractions, then we're just going to follow our steps. We're going to multiply the tops and the bottoms, and then see if we can make the numbers smaller. So 4 times 5 is 20. 1 times 8 is 8. And then if I look at these two numbers, 20 and 8, I recognize that they both divide by 4. So I can say that this is the same as 5 over 2. 20 divided by 4 is 5. 8 divided by 4 is 2. Now you might try and divide this by 2 first, and that would work. 20 divided by 2 is 10. 8 divided by 2 is 4. So you could end up with 10 over 4. But then we have to recognize that we can actually divide by 2 again. 10 divided by 2 is 5. 4 divided by 2 is 2. At this point, it'd be a good time to try the next ones on your own, following these 3 steps. Multiply the tops, multiply the bottoms, and then check to see if you can make those numbers smaller. If I follow along the steps here, okay, 3 times 5 gives me 15. 4 times 7 gives me 28. And then if I think about 15, I can divide 3 into 15, but 3 doesn't go into 28 nicely. 5 goes into 15, but it doesn't go into 28. And I can't think of any other smaller numbers that would go into 15. So this is another one of those examples that we can't reduce. We still want to check, but we can't reduce. Moving on to the next one. 2 times 6 is 12. 3 times 11 is 33. And then checking to see if any number divides into both 12 and 33. I think I can divide 3 into both of them. 12 divided by 3 is 4. 33 divided by 3 is 11. So our final answer is 4 over 11. Moving on to the last example, again we've got a whole number here, so we can put that as a fraction over 1. And then we can multiply 6 times 2 is 12. 1 times 3 is 3. Recognizing that both numbers will divide by 3. So I get 4 over 1. Now it's fine to leave a fraction as 4 over 1, but whenever we see that denominator of 1, well that just means it's a whole number, just like we had 4 over 1 up here. We could also rewrite this as just 4. Okay? Again, you're not wrong to leave it like this, but we try and simplify as much as possible. So you would always see it written just as the number 4. When we move on to dividing fractions is exactly the same as multiplying fractions with one extra step at the beginning. So whenever we see two fractions that we're going to divide, what we want to do is flip the second fraction and change to multiply. So if I look at this 2 over 7 divided by 6 over 5, I'm going to say that I'm going to take that second fraction, 6 over 5, and I'm going to flip it. I'm going to change it to 5 over 6. And it's going to reverse the two numbers. And then I'm going to take that divide and I'm going to change it to a multiply. Once we do this, now we have a multiplying question, so we can go back up to our 3 steps here. If we're multiplying, we can multiply the tops, multiply the bottoms, and reduce if possible. So if I multiply this, I get 10 over 42. And then I recognize that they're both even numbers, so I can divide out a 2, leaving me 5 over 21. Again, we've got a whole number here. We can change that to a fraction, 4 over 1. But because I see divide, I'm going to change it to a multiply. And I'm going to flip that second fraction so it becomes 3 over 2. Multiply the tops to get 12, multiply the bottoms to get 2. Again, I can reduce because both values divide by 2, giving me 6 over 1, which I can write as just 6. One more here. Again, we've got a whole number, but now this whole number is at the end. I can still change it into a fraction by putting it over a denominator of 1. When I take my division, I'm going to keep that first one the same, change my division to multiply, and flip this fraction upside down. So instead of 3 over 1, I now have 1 over 3. And then I can multiply to get 4 over 15. 4 and 15 don't reduce. We can't divide the same number into both of them, so that's going to be our final answer. We can't make the numbers any smaller. Go ahead and try the last 3 on your own, and when you're ready, restart the video to check and see how well you did. Okay, so a dividing question again. So I'm going to change that divide to multiply, take the second fraction, flip it upside down. So 5 over 7 becomes 7 over 5. Multiply the 3 and the 7 to get 21. Multiply the 4 and the 5 to get 20. Check to see if you can reduce, but in this one we can't. So 21 over 20 is our final answer. For the next example, 8 over 3. Change the divide to multiply, flip the 12 over 9 so it becomes 9 over 12. 8 times 9, 72. 3 times 12, 36. Now we got some larger numbers. We can break it down. What can we divide into both 72 and 36? I know that 2 is going to work, but they're both large numbers, so I'm going to try something a little bit larger. Okay, I'm going to start with 6. So let's see, does 72 divide by 6? Yes, it does. So 72 divided by 6 is 12. What about 36? Can we divide 36 by 6? Yes, we can. So we know that we can divide 6 into both of these numbers, which would give us 12 over 6. And now that the numbers are smaller, I can see that I can divide 6 into these again. Okay, 12 divided by 6 is 2. 6 divided by 6 is 1. And if I end up with 2 over 1, well, that's just 2. Okay. So 2 not so nice looking fractions, when we divide them, it actually turns out to be a relatively nice number. For the last one, again, I'm going to take that 6 and make it a fraction with the denominator of 1. 2 over 3 times 1 over 6. Flip that second one upside down. Multiply the top. Multiply the bottom. Get 2 over 18. They're both even numbers, so I can divide out by 2, leaving me with a final answer of 1 over 9. And we will pick this up in the second part of the video, where we will look at adding and subtracting.